Hello students, welcome back. So in this session, we are going to be talking about how can you change the shape of the arrays. Okay, so first thing we're going to do is import our NumPy array. So Control A, Control C, come over here, copy and paste, and there you go. So I import my NumPy as NP. I'm creating an alias for NumPy, and the alias is NP. All right, let's run this. All right, great. Now, first thing we're going to do is going to try to understand flatten. What flatten does is it's an inbuilt method, by the way, and what it does, it converts a multi-dimensional array into a one-dimensional array. This is important. Your final array is going to be ending up as a one-dimensional array. It returns a copy. So if you modify the flatten array, it is not going to change the original array. So that's a good thing. So by the way, why do we even need one-dimensional array? Well, many machine learning models, like for example your logistic regression, your decision trees, they expect your one-dimensional feature vectors, not 2D matrices. Another thing, many CNN models, like convolution neural network models, they require one-dimensional data. So that's why you need a flattened one-dimensional array. Another interesting case is sometimes the data is spatially distributed, and we need that in one-dimensional arrays. For example, in your temperature sensor grid, okay, in a smart building or IoT devices, when these devices are mounted on your buildings, they actually have a 3 by 3 array of temperature sensors. So basically, it's a two-dimensional object. Okay, it has a 3 by 3 array of temperature sensors. So each number represents a temperature, right? So what we do, we actually flatten the data and then calculate the mean, standard deviation, etc. And this way we can find out the average temperature at a certain location. All right, so let's try to understand how do we flatten an array. Let's start with an example. So let's flatten a two-dimensional array into a one-dimensional array. So I create an array. This is my array right here. Okay, and I print my original array, and then I flatten. And all you have to do is just call this method called flatten. That's all you have to do. So I flatten my array, and then I'm also printing with a number of elements just to see how many elements are there. So I'm printing my original array. Okay, this is my original array right here, and this is my original array, and then I'm printing my flatten array. And as you can see, flatten array right here is exactly same as this, except all the elements are exactly same as that, except the shape has changed. Okay, this one actually, if you look at the shape, is 3 by 3, three rows and 3 columns. Okay, 3 rows and 3 columns. In this case, my flattened array has only 1 row. Okay, 1 row and 3 columns. Okay, and the number of elements is 9. In both cases, the number of elements is 9. All right, let's flatten. Okay, let's flatten a 3D array into a 1D array now. So let's do that. Copy and paste. Come over here. All right. So this is my 3D array. All right, this is 2 by 3 by 5. That's the shape of my array. And by the way, how do we know it's a 3D array? Remember in my previous class explained, you just count the number of parentheses, opening parentheses. In this case, the opening square bracket is 1, 2, and 3. Okay, this is how I know it's a 3D array. All right, so I have my 3D array. These are my elements, and I want to flatten that. Okay, so you just call dot flatten. Okay, call this method, and that's going to flatten that. All right, so as you can see, my original array, first I print my original array, and then when you flatten it, it produces those elements. So it's going to produce 9, 5, 3, 4, 5, 1, 9, 5, 3, 5, 4, 1. So each corresponding elements will be present in this place. By the way, the number of elements over here is 30, and the number of elements is over here is 30. Okay, now there's another function called ravel. Ravel does something same. It converts a multi-dimensional array into a one-dimensional array. So the difference between ravel and flatten is that ravel returns a view. In other words, modifying the raveled array can therefore affect the original array. So it is actually referencing the original array. It's not a copy, it is actually the original array. So if you change or modify the raveled array, your original array is going to get changed. Okay, so let's say we have an array right there. Okay, this is my two-dimensional array, and this is the shape of this is 2 by 3. Okay, now I print my array, and then I call the ravel method into that, and I print my raveled array. So copy, come over here, and paste it. And let's run this. So this is my original array. Okay, this is my raveled array, and as you can see, it's 1 2 3 4 5 6 is printing like this. Now I'm changing in my raveled array right here. As you can see, I'm changing the element at index 0 to 99, which is this right here. Okay, I'm changing this one to 99, and then I print my original array A. All right, and as you can see, when I print my original array A right here, it has changed to 99 right there. Okay, by so when I change my raveled array, my original array, the array that it raveled from, that also has changed. So that should tell you that your raveled array is exactly same, is actually referencing the same elements. Okay, so it's called a view. It's a view of your array. Okay, now comes reshape. Sometimes you have to reshape your elements or your arrays. So it is the opposite of flatten operation. And what it does is it reshapes the array to a new shape of the array. But here's the condition that the total number of elements must be the same in your initial and your final shaped array. So question is, can we reshape into any shape? The answer is no. For example, you cannot reshape an array of shape 8 by 4 into 4 by 5 because they both have different number of elements. 8 by 4 will have 32 elements, 4 by 5 will have 20 elements. So that's why they cannot be this cannot be reshaped into 4 by 5. But you can reshape 8 by 4 into 16 by 2, 4 by 2 by 4, 2 by 8 by 2, 2 by 16 because they all have same number of elements, which is 32. All right. So why do we even reshape? Why do we need that? Well, some machine learning libraries like your scikit-learn, they expect 2D input shapes. Sometimes you have to convert a one-dimensional image to a two-dimensional or a three-dimensional format. And sometimes you need a certain 2D structure to do matrix multiplication, transposition, broadcasting. So that's why we reshape. All right, let's look at some of the examples of reshaping. Let me create a few cells. Come over here. All right. So let's create a flatten array. Okay, I'm just using my arrange method. I'm creating a NumPy array from 0 to 70. All right, this is a nifty little trick. It allows you to create array, so I don't have to keep typing 0, 1, 2, 3 all the way up to 17. All right, so I'm printing my original array. Okay, I'm printing my original array, and you can see this is my original array right there. And then I want to reshape, okay, to a two-dimensional array of shape 2 by 9, 2 comma 9. All right. First of all, you ask yourself, how many elements are there in this case? 18. And how many elements would there be in this case? Well, 2 times 9 is 18. So yes, you can reshape this into this. So I'm trying to reshape a one-dimensional array into a 2D array, and the 2D array shape is 2 by 9. So the way you do is you call a.reshape. Okay, a.reshape, and reshape is your inbuilt method, and you specify your 2 and 9 over there, number of rows and number of columns. Okay. And then I print my reshaped array, and then I will print the type just to show you what type that is. It's a NumPy ND array. And then I'm also printing the end dimension so you can see the dimension 2. Okay, and then shape, so just so you can see the shape 2 by 9. All right, and as you can see, this is my reshaped element right there, reshaped array. Okay, now let's try to reshape same one into a 2D array of shape 3 by 6. Can we do that? And the answer is yes, because this one has 18 elements and 3 by 6 will also have 18 elements. So if I run this, you can see this is my reshaped array of dimension 2. This is a 2 dimension because there are 2 opening square brackets, and it is 3 by 6. 3 rows, 1, 2, and 3 rows and 6 columns. 1, 2, 3, 4, 5, 6, 6 columns. All right. I want to reshape my one-dimensional array now to a two-dimensional array of shape 6 by 3. Well, I can do that too, because 6 by 3, if you multiply 6 times 3, the answer is 18, and that's going to work just fine. And as you can see, let me put a little new line over there, so it's a little bit more easy to read. All right, there you go. So reshaped array 6 by 3 is this right here, and you can count the number of elements over here is exactly 18, and the number of elements over here is also exactly 18. Okay, just to play around, let's say, can I change this to 6 by 6? Okay, I want to reshape to 6 by 6. Would it work? Well, if you're saying no, you would be right, and you're gonna get an error. Okay, it cannot reshape an array of size 18 into shape 6 by 6. It has to be 6 by 3. And if I run this, 6 by 3 is gonna work just fine. Okay, now I want to reshape to a two-dimensional array. Before I was doing two-dimension, now I'm doing three-dimension. I want to reshape to a three-dimensional array of shape 2, 3, 3. All right. Well, let's count the number of elements over here. How many are there? Well, 2 times 3 is 6, 6 times 3 is 18, 18 elements. So yes, you can. So I'm going to call a.reshape. Okay, and you specify your 2, 3, 3 in here. You specify your shape inside, and that's going to create your 2, 3, 3 matrix right there. All right. I want to reshape my same array. Okay. Let me create some cells. Okay, I want to reshape my same one-dimensional array with 18 elements into a 3D array of shape 3, 2, 3. All right, so 3 times 2 is 6, 6 times 3 is 18. Yes, it can be done. And when I run this, and you can see, oh, let me put another new line over here so it's a little bit more clearer. And let's run this again, and there you go. So it has reshaped into a 3 by 2 by 3. So there are 3 blocks, 1, 2, and 3. 3, right? That's where this 3 comes from. Sorry, this 3 right there. This 2 means within each block, okay, you're going to have 2 rows. 1 row and 2 row. 1 row, 2 row. 1 row, 2 row. Okay. This one is saying that within each row, you're going to have 3 columns. And each row will have 3 columns. 1, 2, 3, or 3 elements. 1, 2, 3. 1, 2, 3. Second one, this row has 3 elements. This row has 3 elements. Okay. Another way to flatten is to reshape with argument -1. This is something you'll see too. So -1, what happens is that this NumPy is basically an instruction telling to NumPy to figure out the shape by itself. Okay, so let's say we want to reshape, we want to convert a 3D array to one-dimensional array. So this is my 3D array. Okay, I want to convert this into a one-dimensional array. Let me just put this over here so it's a little bit more easy. Okay. All right, and there you go. So this is my 3D array. I want to reshape into 1D array. So come over here and let me just remove that. All right, and let's run this, and there you go. So if you look over here, what just happened was I am specifying dot reshape and I'm putting -1 inside. Okay, and -1, what it does is telling the NumPy array that, hey, look at this right here and figure out what number should go over there. And this is actually, if you look at the shape, what is it? This is like 1, 2, 3, 3 rows and 5 elements. So 3 times 5 is 15. That's 15. So it's going to figure out that this number is 15 right here. So it's going to reshape into a one-dimensional array with shape 1 by 15. All right. Okay. Now, same thing. Okay. Come over here, paste it, and let me just print this one too out over here. Same array. Okay. And now I'm going to try to convert this into a two-dimensional array. Okay. A two-dimensional array of shape 5 by 3. But in this case, I'm not specifying 5. I'm just saying -1 comma 3. Okay, so this is my same array and I'm shaping into 5 by 3. So when you run this, you can see my reshaped. This is my reshaped array right there, and this is my original array. Original array is the first print statement, which is this right here. Okay, this is my first print statement. It prints out my original array and then it reshapes it into 5 by 3. I could have removed -1. I could put 5 over there, but by putting -1, I'm actually telling NumPy to figure out what this number is. Sometimes what happens, you don't know what is the shape of this is going to be. All you know is that whatever this shape is, this has to be 3, but you don't know what this number is. So in this case, you can type -1 over there. Okay, now let's try to convert it into a 2D shape of 5 by 3. So come over here. And the only difference between this and this is that over here now, instead of putting -1 over here, I'm putting -1 over here, and I'm putting 5 over there. Okay, that's all I'm doing. So I run over there, and there you go, reshaped 5 comma -1. So it's gonna figure out what that is, and what that is would be 3. And you can see it's a 3, 1, 2, 3. Over here, when I wrote -1, NumPy figured out that this has to be 5. And so you can see it's a 5 rows. 1, 2, 3, 4, 5. You see that? 5 rows.